Good morning all. We are continuing with our course Watershed Hydrology. In the previous online classes we have discussed about rainfall and its measurement, and now through this we are starting a new chapter, that is abstraction losses. Abstraction losses, we all know what is runoff. We have discussed in detail what is rainfall. So whatever rain falls on the earth, not all of it is used by plants or plants for its growth and development, but a part of it, in fact most of it, is washed away or is wasted through runoff, and some part of it which remains in the soil, this is called the abstraction losses. These abstraction losses may include your runoff, other than runoff, infiltration, transpiration, evaporation, transpiration, then interception, and as well as infiltration. So the total rainfall is minus abstraction loss is runoff. Runoff, you might be aware, or in the next chapter we will be dealing with runoff. What is runoff? That we know preliminary definition of runoff is the water which passes away after meeting the infiltration and interception losses, which flows overland and contribute to river or rivulets, is called runoff, and it occurs as surface runoff, is a surface phenomena. And the abstraction losses are the losses other than runoff. So what are the losses other than runoff? First we have interception, then depression. First, when rain falls on the earth's surface, it is intercepted by the vegetation or any hard surface, buildings, etc. This is called your interception. Then part of it, as we all can also see from this figure, hydrological figure, that when rain falls, this precipitation, first it is intercepted by the vegetation, and part of it is retained in the vegetation, in the canopy of the trees, and the rest is moved to the land surface. And at the same time the evaporation also continues in air as well as on the land surface. Then next, once this interception is there, then part of the rainfall will be filling the depressions on the land. As we know, the land is not a plain surface. There are many ditches, there are many depressions. It will be filled first. Once this interception is completed, evaporation and transpiration is taking place simultaneously. Depression storage is filled, then rest, and even after that, if rainfall continues, it flows as overflow and flow, and this flow is we call it runoff. And this part, that is the interception, depression, storage, evaporation, as well as transpiration, these are called the abstraction losses. So it consists of, you can see, interception, second depression, storage, third infiltration. Yeah, one thing we have forgot. And once this depression is filled, the rainfall, depending upon the soil type, will seep into the land surface through a process called infiltration. So infiltration is the movement of water into the soil surface through a saturated or unsaturated soil. This is called your infiltration. Then evaporation will be there from the land surface as well as in the air too, as well as through the intercepted leaves. Evaporation is a continuing process. Then transpiration, that is the amount of water vapor which is lost or transpired through the stomata of the leaves. This is called transpiration. These all are the components of your abstraction, and these all together is called abstraction loss. Now coming to the first component of transpiration, abstraction loss, that is interception. When rain falls, part of the rain is retained in the canopy of this vegetation or some high rising buildings. It is intercepted. It is not allowed to go to the ground surface or the land surface, and this is called your interception. See, water when it falls, because of this cover, canopy cover, it is intercepted by this cover. It could be vegetation, it could be land, it could be any building or any structural material. It could be forest as well. So there are two types of interception losses. One is called interception loss, other is the interception storage. Interception loss, when we call it interception loss, when the rainwater which is intercepted evaporate back to the atmosphere, such type of loss we call it interception loss. And there is something called interception storage. It happens when the interception takes place on the land surface in the dry leaves. This interception is stored on the land surface and forms a part of the soil moisture regime. Such type of interception is called interception storage, but of course it will not add to the groundwater storage. It will be there as a part of soil moisture which will be later be evaporated. So what are the factors which affect the interception? There are 3 or 4 factors: storm factor, plant factor, canopy factor, or season of the year is also very important, and the prevailing wind. So how these factors affect the interception, we can find out. If the storm factor means the rainfall, the intensity with which the rainfall is falling. So if we have higher rainfall falling, if rain is falling at a higher rate on the land surface, it will the interception would be proportion of the interception would be lesser than the overall rainfall. How? See, if the numerically, theoretically, if the rainfall is, total rainfall is less than 0.25 mm, then it is considered that the entire rainfall is intercepted and is evaporated. Is a transpiration loss. There is no contribution to the groundwater. There is no contribution to the runoff. If the rainfall, the depth of rainfall is between 0.25 to 0.5 mm, then around 20-25% of the there would be interception of 25% of the total rainfall. And if it is more than 1, then only we consider it as an interception where the interception is more than 50%. Second is the plant factor. The interception will also depend upon the type of vegetation or the type of forest that we have, forest cover that we have. Whether it is conical, whether it is fan shaped. If it is elongated conical shape, then the interception would be less because there would be less vegetation in such type of system. If the plant canopy is fan shaped, if it is broad, the canopy is broader, then there would be more surface area to be intercepted. In such cases, the interception would be higher. Then again, the season of the year also determines how much would be the interception. Say if the rainfall is happening in season where it does not permit too much vegetation is not there, like in the dry months, like in the months of March, April or May, where the vegetation is little dry. In such type of scenario, your interception would be less because the plant vegetation at that time would be less. Similarly, in the rainy season or in the spring season, when the crops, trees are at the full bloom stage, where the vegetation is, or the vegetative index technically is very high, then such type of places the interception would be high. So you mind one thing, if interception is high, that means more amount of rainfall is intercepted, and it is a good sign as far as soil erosion is concerned, because if interception is more, it will reduce the impact of the rainfall. Second, and rain that would be going to the soil would be at a lesser rate and at a lesser energy. Third is the prevailing wind. The prevailing wind, wind speed, the wind direction also determines how much interception would be there. It will affect in two ways. Number one, by if there is a higher wind, the evaporation rate from such surfaces would be high. And second, wind speed also decreases the rate of interception. You can see from this graph, initially when the canopy surface is dry, their interception would be high, and as the time passes by, the interception starts reducing, because once the leaves are wet, then what will happen, it will give a channel, it will give a path for the rainfall to seep into the stem and ultimately to the land surface. Second component is your depression storage. As we have discussed in the first slide, that the depression storage is the small ditches, furrows which are there in the land surfaces, ponds or small nalas which are dry, or depression is there. Whenever rain falls, after meeting the requirement of interception and evaporation, it will go to the depressions. It will first fill the depressions. Once this depression is filled, if rain continues even further, then there would be runoff. So the depression is that for part of your total rainfall, which facilitates increase in depth of all the depression, and once it is fully covered, then there will be rainfall taking place. At the same time, once this depression is filled, there would be infiltration as well simultaneously. Infiltration as well as evaporation. This table shows how different land surfaces behave as far as depression storage is concerned. Depression storage from large paved areas, it is much lesser, and as we go to open fields, woodlands or forest land, there the depression storage, because there you find the undulating topography, there depression is this depression storage is very high, and at roofs where it is flat, the depression storage is much lesser. And this figure also shows how percolation and infiltration takes place in the saturated and unsaturated condition. This we'll discuss in the coming slides. Next component of your abstraction losses is infiltration, and this is a very important component as far as hydrology is concerned. Infiltration, as we have already studied, is the downward movement of water, or the downward movement of water from an unsaturated soil. We call it infiltration. There is a difference between infiltration, seepage and percolation. What is that difference? Infiltration takes place in an unsaturated condition, that is when the soil is dry. The movement of water in the soil profile in dry condition, we call it infiltration. And percolation is when the soil profile is filled, when the pore spaces are filled with water, then if movement of water takes place in such type of condition, we call it percolation. And there is one more term, seepage. Seepage is when water enters, seeps into the soil surface. A part of it, there would be vertical downward movement as well as horizontal movement, and this horizontal movement of water is, we call it seepage. This is also one kind of infiltration, but the movement of water takes place both vertically as well as laterally. Infiltration rate, which has got a dimension of velocity, is a function of the soil with which at the function of the soil through which it takes water into, or allows the movement of water into the soil, or the maximum rate through which at which water enters the soil in the soil surface is, we call it the infiltration rate. And this is again a function of your property. This is a property of soil which allows this type of movement. So in the it will depend upon type of soil, which type of the soil we are talking about. If it is sand, it will differ according to the soil type, whether it is clay, silt or loam. There is something called infiltration capacity or the intake rate. The infiltration capacity or the intake rate is the rate at which, or it's the property of the soil through which it absorbs the ponding water or any water which is applied to it. That capacity we call it infiltration capacity or the intake rate of the soil. It again depends upon the antecedent moisture condition. If the soil is already saturated with moisture, the rate of infiltration would vary. If it is dry soil, the infiltration rate would be very high, as in the case of initial. During initial time when rainfall occurs, the infiltration rate is very high, and as the time progresses, the infiltration rate decreases, and after some time it reaches a constant rate. And this constant rate, where the infiltration rate does not differ much with the time, is called your basic infiltration capacity or the basic intake rate. So what is basic intake rate? It is the rate of intake of soil, or it's the rate of infiltration rate where the infiltration rate remains constant with respect to time. And this basic intake rate or infiltration capacity will differ from soil type to soil type. Suppose we consider sand, silt and loam, silt and clay. See, focus your attention to this graph. We see the in case of sand, the initially when the rain falls, when the process of infiltration starts, the infiltration rate is very high, and as the time passes by, it is on the decreasing trend till a time when it will reach a constant value, and this constant value is called your basic infiltration rate. In case of say silt, the infiltration is much lower than sand, and again in case of clay, it is the fine clay, the infiltration rate initial as well as the final is much lower than sand or silt. This table shows the different types of soil particles, soil texture, sand, sandy loam, loam, clay. Here see the difference in basic infiltration rate, which is expressed in mm per hour or centimeter per hour. In the case of sand, it is around 30 mm or 3 centimeter per hour. But in the case of clay, it is even lesser than 0.5 centimeter per hour. There is 6 times difference it is there. So whenever we plan a irrigation, we plan irrigation schedule, or when you are a irrigation planner or irrigation engineer, you have to determine the water requirement or the time of irrigation based upon the soil type as well, because if from sand to loam there is 5 times or 6 times difference in the basic infiltration rate. If you apply sprinkler, you have to design sprinkler or maybe surface irrigation as well. This thing has to be taken into account, which type of soil we are dealing with, because different type of soil will have different type of infiltration rate, and its infiltration character will differ. Now coming to factors affecting infiltration rate. So there are many climatic as well as other factors which determine the infiltration rate of soil. First is the formation of a thin contact layer on the soil surface. if you have seen paddy growing at some place, you might have seen whenever we grow paddy in the general method, by general method, ponding of water in a leveled surface or a plain surface is always desired. So because of this incessant ponding of land, because always it is desirable to have at least 5 or 10 centimeter of water in the paddy field. Because of this practice, what happens is the finer clayey particles get into the interspaces of the soil, or and it blocks the soil, and it will form a thin layer. As a result, there will be cementing of the outer layer, and it will behave as a impermeable layer, so almost impermeable layer. So water is retained at more amount of time. So in such scenario, what will happen is infiltration rate decreases, because in such cases the pore spaces, the void ratio is very less. Pore spaces is filled with your finer particles, and it blocks the movement, intermovement of the soil beneath the soil surface. This is one of the factors which affects the infiltration rate, especially in rice growing areas. Second is soil compaction. What is compaction? Compaction, in second or third semester you might have studied soil mechanics. There you might have studied porosity, void ratio, things like that. Soil is made of three things. There is air there is water, there is solid particles. So there is space between each soil particles is bounded together. There would be some space for air as well. When this air space or the aeration decreases, then the void ratio or the spaces between interspaces between soil particles reduces, then it will become more compact. And if compaction is more, then the infiltration rate will be less. Third is cracking of soil, soil cracking. This happens in arid area, and especially in, it's a characteristic of black soil or black cotton soil. Because of continuous dry atmosphere and alternate dry and wet type of atmosphere, the soil swells, and again it dries. Because of this swelling and drying, there would be cracks in such type of soil, especially in clayey black soil. So when these cracks are wide open, so it will allow more water to get into the soil. When such type of cracks is there, then infiltration rate is much higher, and this is not desirable. Always we desire that we should be having higher infiltration rate, so that the runoff is reduced, soil erosion is reduced. But in this case, because of cracking, this cracks widens, and this affects the cultivable soil. Large amount of cultivable soil is lost because of cracking of the soil in the dry season, especially in the arid region. Third is crop rotation. Crop rotation is one agronomic practice in which at the same plot of land, we shift the cultivation, we changes the pattern of cultivation. Say this is 4 patches of land. In the first year we have chosen 4 different types of crop, and it's always advisable to have crop rotation to maintain the soil health. Say in one patch, in 1 year we have cultivated a particular crop, in the second different crop, third yet another different crop. But when we change the season, in the second season, the first crop which we have cultivated in the first season, it is replaced by the second crop. Similarly, the other 3 are also replaced. So in the same plot, in different seasons, different type of crops are taken, and normally a mixture of crops are taken. Like one would be cereal crop, and other would be leguminous crop, so that its root will not compete with each other. In such type of situation, when crop rotation is there, such type of situation, crop rotation will increase your infiltration rate, and this is considered a very healthy type of system, where the infiltration rate is increased because of crop rotation. Third, we have discussed this tillage operations. Because of tillage operations, because of using heavyweight implements and its overuse again and again, what will happen is the soil pan gets hardened. In such case, the compaction would be very high. Say in the case of rotavator, maybe tractor moving in this field, heavy equipments moving in the field, this will increase the compactness of the soil and thereby reduces the infiltration rate. Third is soil erosion. In soil erosion, when the impermeable layer is exposed or and the hard surface comes in the forefront, in such type of situation, if the impermeable layer, the hard surface is impermeable, it will reduce water intake or water infiltration. If the impermeable layer, there is some cracks there, what will happen is there the infiltration rate increases. It depends which type of hard surface is being exposed. If the A horizon, that we call it in the soil science term, A horizon is exposed and the impermeable layer which permits water transmission is exposed, then soil your infiltration rate would be higher. If impermeable layer is exposed, then the infiltration rate would be lower. Soil texture and structure. You know what is texture, what is structure? You might have studied in your elementary first year courses. Texture is the proportion with which, in which sand, silt and clays are distributed in the soil. And structure is the way of arrangement, the way these particles are arranged in the soil profile. So this texture and structure is also affects the infiltration rate. We have, in the previous slide, we have seen how I have shown you how sand particles, the water intake or infiltration rate is much higher than your clay particles. Soil moisture or antecedent water content in the soil also affect the infiltration rate in the soil. If there is antecedent moisture, if soil is moist, and from the moist surface the infiltration rate would be lesser, and for dry soil the initial infiltration rate would be very high. And the presence of organic matter and microorganism also influence the infiltration rate. This is a healthy condition. If there are organic matter, more carbon in the soil, then the infiltration rate in such type of scenario would be very higher, and this is considered a very healthy sign. Now there are various indices through which we can measure or which can estimate the abstraction losses. The abstraction losses are estimated by two indices. One is called phi index and second is W index. And all this such of in phi index, we assume that a constant rate of intake value of soil during the entire duration of rainfall takes place. If you see this graph, what is this? This is a rainfall intensity versus time. Which type of graph is it called? You might have studied, we have discussed in our online classes. Recording type rain gauges, then mass curve, intensity of rainfall. What was it? Hyetograph. Hyetograph, you know. This is the hyetograph of a obtained from a recording type of rain gauge. And this is the rainfall volume with the passage of time, right? And this part is your abstraction loss, and we call it the phi index. This includes the abstraction, that is water which is infiltrated into the soil. This comes under this infiltration losses, and the rest is your runoff. Here the excess rainfall is almost equal to the runoff volume, or the runoff volume after separation of base flow in a runoff hydrograph. What is runoff hydrograph? We will be discussing when we deal with hydrograph or runoff. And this W index, we do not take into account. Here we have taken into account only the infiltration, only the losses. In W index, even the your interception losses is also taken into account here. But because of difficulty in finding the interception losses, this W index is not very popular. We normally, when we have to find the infiltration losses or as abstraction, we go for the phi index. There is a procedure for determination of phi index. First, we have to draw the hydrograph of the storm and compute the total volume of the rainfall. What is hydrograph? That we obtain from mass curve or the recording type of rain gauges. Now we have to compute the excess runoff volume from the storm hydrograph. Then subtract the second one from the first one, and dividing this we get the phi index in centimeter per hour. We will deal with this during any of the practical classes. In this platform it would be a little difficult to explain you. Then phi index is the total intake of water into soil divided by the effective time period. There is one problem based on this. A storm with 20 centimeter of precipitation produced a surface runoff of 11.6 centimeter. Estimate the phi index of the storm if the data recorded is as follows. This is your storm time, first hour, second hour, third hour, up to 8th hour. That means in the entire duration of the rainfall is 8 hours, and at each hour interval we are getting this much of rainfall, 0.8, 1.8, like this, so on and so forth. At the last 8th hour we are getting 1. Now how do we find the phi index here? The infiltration rate of the rainfall in the soil is 20 is the total rainfall minus the 11.6 is runoff. Total infiltration taking place is 8.6, 8.4. Now this is the basic assumption for phi index, finding the phi index, that we have to take the full storm period, that is 8 hours. Then the phi index is total infiltration divided by 8, that is 1.05 centimeter per hour. But here if you observe this table, the phi index or infiltration rate cannot be more than your rainfall, but it is happening here. In the first hour rainfall is 0.8 and the phi index that we are getting is 1.05. Is it possible? It is not possible, because infiltration cannot exceed the rainfall. That's a basic logic. So we have to neglect this one. Is this happening anywhere else? Here the rainfall is higher. It is here. Here at the 8th hour you see the rainfall is 1 mm or 1 centimeter, and the phi index or the infiltration is 1.05 centimeter per hour. This again is also not possible, because this cannot exceed the rainfall, except in the case if you are providing water externally. But in this case we are not providing water externally, we are only talking about the rainfall, storm. Now what we have to do is, now we can neglect the first and the 8th hour where the phi index exceeds the rainfall. We will not take first hour and 8th hour, and we will take the time period as 2 to 7 hours, that is 6 hours. Now the phi index for this 6 hour would be 20 minus 0.8 we have to we are deleting, 1 we are deleting. Now for 6 hour effective time period, the total rainfall is 6.6 centimeter, or total phi index or total infiltration is 6.6 centimeter, and therefore the phi index will be 6.6 divided by 6, that is 1 point something, 1.1. Here from 2 to 7 if we see, 1.1 is not exceeding anywhere. The rainfall is not exceeding. So this is the phi index for this problem. We can do a physical verification of this. It can be verified how? Say this was our problem. From 1 to 8 hours we had this rainfall. So the excess rainfall after reducing 1.1 centimeter, that is the new phi index, is at the second hour it is 0.7, third hour 1.9, fourth hour 3.5, sixth hour 2.1, seventh hour 0.9. Therefore the total excess rainfall is, the total excess runoff, it was in the given in the question, it was 11.6, and the total excess runoff that we are getting through this phi index method is also 11.6. That means our problem, that the way we have solved it is right. So that's all from my side today. I would be giving some assignments based on this, a few problems, and if there is any doubt in your mind, you can also always get in contact with me. Thank you very much.